Hi everyone. In today's lesson, we're going to write parabola equations given parts or pieces. So before we can do that, I first want to review the information that we learned yesterday. So modified vertex form of a parabola is x minus h squared equals 4p y minus k, where our vertex is the point h comma k, which is the opposite signs in the formula, right? If it's a negative h, it goes to a positive h. It's if a negative k, it goes to a positive k. So you can write switch signs if that helps. And p is your distance from the focus. I'm going to put F for focus. From the focus to the vertex, V for vertex, or the vertex to the directrix. Now remember, if we have a p-value that's greater than 0, it shouldn't be 1 here, it should be a 0. So where p is greater than 0, that means we have a happy parabola. And if p is less than, not 1, but 0, if p is less than 0, we have a sad parabola. So that brings me to my two pictures. So if I have a happy parabola, a parabola that opens upward, we know that the turning point is always the vertex of your parabola. We know that the focus is always inside the parabola, and the directrix is the line entirely underneath it. We also know that the distance from the focus to the vertex is p, and we also know that the distance from the vertex to the directrix is also p. If we have a sad parabola, or a parabola that opens down, we still have our turning point as our vertex of the parabola. We still have the focus that lies inside the parabola. And now this time the directrix is completely above the parabola. And the same thing goes. The distance from the directrix to the vertex is p, and the distance from the vertex to the focus is also p. All right, let's try an example. So example number 1 says, given a focus of 3, -4, and a directrix of y equals 1, I'd actually like to change this to say a directrix of y equals 2. It says, find the equation of the parabola in modified vertex form and graph the parabola on the axes provided. So bottom line, we need to find the equation of the parabola in modified vertex form. So we have x minus h squared equals 4p y minus k. So the first thing we know is that h comma k is our vertex. So we don't have that. We have a focus and a directrix, so we need to first find this. So the best way I can suggest doing that is by graphing what you have. So you have a focus of 3, -4, which we're going to put right here, and we're going to label that with an F. Then we have a directrix at the line y equals 2, and we know that y equals is the horizontal line through the y value of 2. So we're going to label this with a D. So if we go back up here for a second, we can see the scenario at play. We have a directrix on top with a focus underneath it. So since we have a directrix on top with a focus underneath it, the vertex should be right in the middle. So we're going to go back here now and count and find the middle. So let's count how many spaces there are from 2 to -4. So 1, 2, 3, 4, 5, 6. So since there are 6 spaces total, halfway would be 3. So I'm going to go 3 up or 3 down and label that with a vertex. Now that 3 here is your p-value. But since we know that we're going to have a vertex and a parabola that's going to open downward, we must make p negative. So we know from here that our p-value is going to be -3. We just found our vertex, which was, I'm just looking at this point here, 3, -1. So now we can go ahead and write our equation. So x minus h, well, remember we have to switch the sign. So if the vertex is a positive 3, we're going to put it into the equation as a negative 3. And then we have 4, p is negative 3, and y. Now, since our vertex is negative 1, our y value, we're going to switch the sign. So we're going to make it a plus 1. And if we simplify this, we have x minus 3 squared equals negative 12, y plus 1. And that is our modified vertex form. So this negative indicates that we have an opening down parabola, or a parabola that opens down. So now, just to answer the rest of the question, it says graph it. So let's finish this. We know to graph that we have to go double the p-value left and right of the focus. So if my p-value is 3, we're going to count 6 from this focus. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we're going to connect from the vertex, and that is my parabola, where here the distance from here to here is 2p, and the distance from here to here is also 2p, which is 6. All right, let's try another example. All right, let's look at example number 2. Please change your directrix to say y equals negative 1. Okay, so the same directions, they needed the equation of the modified vertex form. So x minus h squared equals 4p, y minus k. So I first plot the negative 2, 3, which is right here, is my vertex. And I have a directrix of the line y equals negative 1. So I know that since the directrix is completely beneath the vertex, that my parabola is going to open up. So let's count what we have so far. So from the vertex to the directrix, it looks like we have 1, 2, 3, 4 spaces. So that's going to tell me I need to go 4 spaces up and put another dot. So 4 spaces up, 1, 2, 3, 4. This is your p equals 4. This is going to be my focus. And if we wanted to graph this parabola, we're going to do double the p-value, and we're going to go left and right that amount from the focus. So from this focus point here, we're going to go over 8. So 1, 2, 3, 4, 5, 6, 7, 8. And we're going to put a dot. And then we're going to go left 8. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to put a dot. And if we are connecting, we connect from the vertex. And this would be my equation of my parabola. So let's put all this information now into my modified vertex form. So from the graph, we can read that my vertex is the point 2, 3. And from the graph, we have a p-value of 4, and it's positive 4 because the parabola is opening upward. And that's honestly all we need for our equation. So let's go ahead and plug in. So we have x, whatever the vertex sign is, we're switching them. So since it's a positive 2 and a positive 3, they're going to go into the equations with minus signs. So minus 2 squared, 4p is 4, and y minus 3. So if we simplify, x minus 2 squared equals 16, y minus 3. And that is my equation. All right, let's take a look at example number 3. So given a focus of 4, 0, so I'm just going to plot that. 4, 0 is my focus. And given a vertex of 4, 3, so I'm labeling that with a vertex, same thing. Find the equation in modified vertex form and graph. So where's the location of the focus? It's beneath the vertex, therefore my parabola is going to open down because the focus has to be inside of it, right? So let's just keep counting. So we have 1, 2, 3. So we're going to go 3 above, and we're going to put a dot. And that dot is going to contain the entire line of the directrix. So this directrix, D, is the line y equals 6. So if we want to continue to graph this thing, we know this was 3 and this was 3, right? That's our p-value. So p equals 3, p equals 3. We can count 6 from our focus. So 6 to the right and 6 to the left, and we can connect from our vertex. And that is my graph, right? The distance from here to here is 2p. Distance from here to here is 2p. So let's make our equation now. So we have x minus h squared equals 4p y minus k. We know that our vertex, it was given to us in the problem, was 4, 3. And we had to find our p-value. So our p-value we found was 3, but since the parabola is opening down, we're going to label p as a negative 3. And we're going to go ahead and plug this into our modified vertex form. So x minus 4 squared, I changed the positive 4 to a negative 4, equals 4p, p is negative 3, and then y minus 3, that's our y value, switch the sign, and we can just put this together. So x minus 4 squared equals negative 12, y minus 3. And that is my equation. All right, that's it for today. If you guys have any questions, now is a good time to jot them down, and we'll see you in class tomorrow.